Microfluidics is the study of fluid behavior through the precise control of fluids at the micro and nano scale.
It's a technology that's been proven and used in the biomedical industry for decades, most notably with diabetes test strips and pregnancy tests. But this technology is ideally suited for oil and gas applications. Why? Oil and gas reservoirs are essentially huge rock sponges made of tiny channels that are micrometers or even nanometers in size. So when we say tiny, we mean really tiny. 100 nanometers is about 1/5000th the thickness of a strand of hair. How oil and gas flows through these tiny channels is the driving force behind our entire industry. With the shale boom occurring in North America, we're now producing from rocks with hydrocarbons locked in tiny nanochannels and pores. These shale reservoirs are only giving up 5 to 10% of the available hydrocarbons trapped in those rocks.
Shale reservoirs were only made economical through the advent of hydraulic fracturing and horizontal drilling technologies. That means we're still leaving more than 90% of the oil we're looking for in the reservoir.
So how do we unlock the trapped hydrocarbons? Even more innovation and technology will be necessary to see these recovery rates increase, and the industry is racing to be the first to find them. One key piece to the recovery rate puzzle is the optimization of chemicals used to stimulate and produce these reservoirs during fracturing operations, which means studying fluid flow at the nanoscale. Until now, it was very difficult in the laboratory to replicate and study these tiny confinements that we see in the field. Microfluidics, and now nanofluidics, is the technology that enables operators to reproduce underground conditions in a laboratory. This technology can flow stimulation fluids through replicated rock and identify which of those fluids could help recover more oil and mitigate damage caused by fluid incompatibilities on a well-by-well or pad-by-pad basis. This is done by fabricating analogs that replicate specific rock properties, followed by running the suite of tests at reservoir conditions, like temperature and pressure, with a high level of system control and repeatability. This system control and repeatability are well-known advantages of microfluidics, not possible with other laboratory tests.
Thanks so much for watching. If you want to learn more, go to interfacefluidics.com or email us at info@interfacefluidics.com.